Hello everybody. Let's revise carbonyl compounds today. So what are carbonyl compounds? All aldehydes and ketones are carbonyl compounds. Okay, right? So all aldehydes and ketones are carbonyl compounds, and hence this carbon is called the carbonyl carbon. This carbon is called the carbonyl carbon. If CHO is present, this is an aldehyde, and if there is no CHO, we have again R or R dash, then this is a ketone. But this sp2 carbon, which is connected to oxygen atom via double bond, is called the carbonyl carbon. Okay, another important point is, in this carbonyl carbon, okay, because oxygen is much more electronegative than carbon, this pi bond has a tendency to shift towards oxygen. And once this pi bond shifts towards oxygen, a nucleophile which is negatively charged can attack this carbon. Hence we say aldehydes and ketones show nucleophilic addition. This process is called nucleophilic addition. The nucleophile may be negatively charged or neutral, depending on what nucleophile we have chosen. But the basic premise is that all carbonyl compounds undergo nucleophilic addition. Right? Okay. So the basic reaction is nucleophilic addition. There are various types of reactions in this chapter. This chapter is extremely important. Okay. And we all know that this carbon is carbonyl carbon, which is sp2 hybridized. Let's start with the questions. First question. Acetaldehyde on warming with Felling's solution gives a red precipitate of. Now what is Felling's solution? If you remember, Felling's solution is a solution used to test the presence of non-aromatic aldehydes. That means if an aldehyde is reacting with Felling's reagent or Felling's solution, we will say that it is producing a red or a reddish brown precipitate of Cu2O. So if an aldehyde is reacting with Felling's solution, it gives us a precipitate of Cu2O. Non-aromatic aldehydes undergo this reaction, but aromatic aldehydes do not react with Felling's solution. Okay, what about acetaldehyde? Acetaldehyde is CH3 CHO. This is acetaldehyde. IUPAC name is ethanol. Clearly you can see that this is not aromatic because there is no aromatic ring here, and hence this will undergo reaction with Felling's solution to give us a reddish brown precipitate of Cu2O. What is Cu2O called? This is called cuprous oxide. Don't get confused. This is cupric oxide. This is cuprous oxide. Cu2O is cuprous oxide. If we take benzaldehyde, then this will not react with Felling's solution because the carbonyl carbon is directly connected to aromatic ring. This is phenyl ring, this is aromatic. So this will not react with Felling's solution. Similarly, if we take this compound, again this is an aldehyde, but again this is connected, this carbon is connected to aromatic ring, hence this will not undergo reaction with Felling's solution. So we will say such aldehydes do not reduce Felling's solution. Aromatic aldehydes do not reduce Fehling solution. Next question. Acetone does not form. Okay, what is acetone? This is acetone. The common name is acetone. The IUPAC name is propanone. Right? The IUPAC name is propanone. The common name is acetone. Now, this is a ketone. Ketones don't react with Tollens reagent. Ketones don't react with Fehling solution. Hence, we will say a ketone does not reduce Tollens reagent. A ketone does not reduce Fehling solution. Right? So, it does not form any product when treated with Tollens reagent. And so, we will say that no silver precipitate, that is Ag, silver mirror we call that. So, all aldehydes react with Tollens reagent, but ketones don't react with Tollens reagent. So, acetone does not form a silver mirror with Tollens reagent. Next. CH3CHO and CH3CO, CH3 cannot be distinguished by. Okay, cannot be distinguished by. Now, see, if both these compounds are reacting with a particular reagent, then we will say that we will not be able to distinguish the two of them, because both will produce products, both will give us products. And in case a particular compound reacts with something and the other does not react with that same thing, then we say that yes, we are able to distinguish the two on the basis of the reagent. In this case, they have asked us to identify the reagent with which both will react, and once we say that both of them will react with that reagent, we will say that they cannot be distinguished using that reagent. So it is Grignard reagent, because Grignard reagent is RMGX, and we know that Grignard reagents react with aldehydes. Also, Grignard reagents react with ketones. Grignard reagent, right? Grignard reagent reacts with aldehyde also, it reacts with ketone also. Fehling solution is definitely used to distinguish an aldehyde from a ketone, because this aldehyde will undergo reaction with Fehling's reagent, whereas the ketone will not undergo reaction. Same holds true for these two. Aldehydes will react with Schiff's reagent, aldehydes will react with Tollens reagent, but ketones will not react. Hence, B is the answer, because with Grignard both will react. This will also take place, this reaction will also take place. Next. In the reaction, alright, let's see now. CH3CH2COOH is a carboxylic acid, alright, and it is treated with moist Ag2O and heated. Okay. After that, it is treated with bromine CCl4 and then Mg ether, and then followed by further reaction with CH3CN. All right. Now, notice carefully, they have asked us to identify product C. Okay. Now, CH3CH2COOH, this is a carboxylic acid. This is a carboxylic acid. This is a carboxylic acid. All right. Then this is treated with moist Ag2O. So this moist Ag2O is equivalent to AgOH. A carboxylic acid is reacting with a base. So AgOH is a base, right? Acid reacts with the base to give salt and water. So what is the salt? So I will say that once this reacts with AgOH, we will get this as the salt. This is the salt. Right? Okay. Then this salt is treated with Br2CCl4. Okay. Fine. RCOOAg is a silver salt. If RCOAg is treated with Br2, we get RBr. This is A. Then if I treat this with Mg ether, I get B. This is B, Grignard reagent. And then Grignard reagent is treated with CH3CN. This is a nitrile followed by acidification. Now if RMgx is treated with R-CN, we get RCO, CO and then R dash. This is a ketone. So what is R here? CH3 is R. And what is R dash? Even in this case, R dash is same. That is, R dash is also CH3. So this is the product, right? Okay. Oh, we made a small error. We did not count the number of carbon atoms properly, right? This is how it is. See, there are 2 carbon atoms here. So we had missed that. So it is CH3, CH2Br. There are 2 carbon atoms here, right? So this is the ketone finally obtained, that is butanone. Butanone. So C is the correct answer. So RCOOAg plus bromine gives RBr, RBr plus Mg is RMgBr, and then if a Grignard reagent is treated with a nitrile in acidic medium, we get a ketone. So RCOR dash. So this is R dash, that is R dash CN is the nitrile. This is RMgx. So RMgx plus R dash CN in acidic medium, we get RCOR dash. So this is the answer. So a ketone is obtained. So C is the correct answer. Okay, next question. Acetone is obtained by the hydrolysis of the addition product of methyl magnesium iodide and similar question. See, what is methyl magnesium iodide? Methyl magnesium iodide. This is methyl magnesium iodide. And if I treat this with a nitrile in acidic medium, just now we discussed that if a Grignard reagent is treated with a nitrile in acidic medium, we get a ketone. So we'll get CH3 COR. Now we want to obtain acetone. Acetone is what? CH3CO CH3, which means R is CH3. That means the compound is CH3CN, right? CH3CN. This is called acetonitrile. You should know this name. So D is the correct answer. I hope things are clear so far, right? Okay. Next question. Okay, we have a compound which has 2 chlorine atoms connected to the same carbon, all right? And then that is being treated with aqueous KOH. AQ dot means aqueous. So in aqueous KOH, we all know that OH minus is present. There is a good amount of OH minus. OH minus is a very good nucleophile. It's a good nucleophile. It's a negatively charged species. OH minus is hydroxide ion. And whenever we come across aqueous KOH or aqueous NOH, we will focus on OH minus. Now OH minus will act as a good nucleophile, and so what is A? A will be obtained if I replace both the chlorine atoms with OH. So substitution reaction is happening. But then two OH groups on the same carbon are never stable, so don't make this mistake. You cannot say this is A. So this is not A. Why? Again, I'm repeating, two OH groups on the same carbon are not stable. Immediately you have to convert it to C double bond O. So this is the correct product if I talk about this reaction. So A is acetophenone. This is called acetophenone, right? What about B? Now this is treated with KCN. So a ketone reacts with KCN. Cn minus is a good nucleophile. We know that a ketone shows nucleophilic addition. This will attack the carbonyl carbon, and hence we will get this followed by acidification in order to neutralize the negative charge. Right? Okay. Now, if you look at this carbon, this is a chiral carbon. Initially, this carbon was not chiral because this was sp2. And now this is sp3. And also it is chiral because there are 4 different groups attached to this. So, initially there was no chiral carbon, but afterwards that same carbon which was not chiral has become a chiral carbon. This means that there are 2 possibilities. We will get 2 products. One of the products will be the compound in which this carbon has R configuration, and the other product will be the compound in which this carbon has an S configuration. Means which, what does that mean? This means that we will obtain a mixture of 2 products. Such a mixture is called a racemic mixture because both the enantiomers will be present in equal quantities, and so A is the correct answer. 50% D and 50% L. That means this is dextrorotatory and this is levorotatory, right? Both the enantiomers are present in equal quantities because this carbon is now chiral, and we will obtain a mixture. One of the products will be the compound in which carbon has R configuration, and the other compound will be its enantiomer. So we have both the products in equal quantities or in almost equal quantities, and hence we'll say A is the correct answer because a mixture of 2 enantiomers in equal quantities is called a racemic mixture. So A is the correct answer. 50% D and 50% L, that means it's a racemic mixture. Next question. Benzophenone. This is called benzophenone. This is called benzophenone. Benzophenone can be obtained by, okay. So RCOCl plus R-2CD, yes. We will get a ketone, so we will get benzophenone here, right? Here also, if you see, this acts as a nucleophile, and but then here we will not get benzophenone because the product will be this. In B, this will be the product, right? O will attack. This is the product obtained. This is an ester. COO is an ester, right? But we want a ketone. So A is the correct answer. Now what is this A? In detail I will write. This is RCOCl plus dialkyl cadmium. So from here you get RCO R dash. But in this case, R and R dash are same because pH also means this phenyl ring itself, right? Hence A is the answer. Which does not react with NaHSO3. This is called sodium bisulfite. sodium bisulfite. First of all, we should remember that all aldehydes react with sodium bisulfite, right? So aldehyde, aldehyde, aldehyde. So A, B and D will definitely react with sodium bisulfite. All aldehydes react with sodium bisulfite. There are some ketones which do not undergo reaction with this because of steric hindrance. If the steric hindrance is too much in a ketone, if there are bulky groups attached on both sides of the carbonyl carbon, then such a ketone does not undergo reaction with sodium bisulfite. Hence, C is the correct answer. You can clearly see this is a bulky group, this is also a bulky group. Both these bulky groups are connected to this carbonyl carbon. So C does not undergo reaction with sodium bisulfite. Likewise, benzophenone also will not undergo reaction with sodium bisulfite. So even this will not undergo any reaction with sodium bisulfite. Next one, ketones can be prepared by. So this is particularly used for aldehydes, I mean for preparing aldehydes. This is again used for preparing benzaldehyde. This is not a method of preparation of anything. This is a reaction given by aldehydes, a few aldehydes which lack alpha hydrogens. So this is the correct answer. Now how does this give us a ketone? Now Friedel-Crafts reaction is of two types. One is Friedel-Crafts alkylation and the other one is Friedel-Crafts acylation. With the help of Friedel-Crafts acylation, we can get a ketone. So let's check an example. Let's see this. So let's say I have benzene and I treat benzene with RCOCl in the presence of anhydrous aluminum chloride. So what will happen? I'll get a ketone. So this will be the product. So I have obtained a ketone. So this is Friedel-Crafts acylation. This is acid chloride, right? What happens here? This electrophile is generated and then this electrophile is attacked by the benzene ring and we get this. So this is the electrophile here. Next question. Which does not produce iodoform when treated with iodine in the presence of NaOH? Alright. First of all, let's look at those types of compounds which produce iodoform when treated with I2 in the presence of NaOH. So all alcohols of this format undergo reaction with iodine in the presence of NaOH to produce iodoform. So yes, if this is treated with NaY, I'll definitely get iodoform. This is called iodoform. It's a yellow precipitate. And if I have such a ketone, this is called a methyl ketone, then also I will get iodoform. So a yellow precipitate will be obtained in this case as well. And if I have an aldehyde, that is CH3CHO, acetaldehyde. So even acetaldehyde undergoes reaction to produce iodoform. So these are the compounds, or I should say these are the different types of compounds which show a positive result in iodoform test. Now what is NaY? NaY is nothing but it is another way to write NaOH plus I2. Okay. Let's look at the options. Pentan 3-one, propan 2-ol, ethanol and ethanol. Okay. Now see, if this odd is H, then I'll get what? CH3CH2OH. CH3CH2OH is ethanol. So even ethanol gives a positive result. So even ethanol will give me iodoform. Which does not produce iodoform? This is the question. Which does not produce iodoform? So answer is A. Why? Let's look at A. Pentan 3-one. So this is pentan 3-one. This is pentan 3-one. Now this is not of this format. Because if you look at the carbonyl carbon, it's not connected to any methyl group. Hence, it will not undergo reaction to give iodoform. Hence, A is the correct answer. Very, very important reaction. You have to be very thorough with iodoform reaction. This is also called iodoform test. Why are we using the word test? Because we are getting a yellow colored precipitate. In chemistry, if we get a particular color as a, for a reaction in which we obtain a product which is colored, and also if there is a reaction, let's say, where we get a product which has a characteristic smell of its own, then we all say that these are tests, or these are used as tests for detection. Next question. We have discussed this already. Carbonyl compounds readily undergo nucleophilic addition. C. Option C is the correct answer. So, which is the electrophilic center in carbonyl compounds? If I ask you, in aldehydes as well as ketones, which is the electrophilic center? You will say this is the electrophilic center. So the carbonyl carbon is acting as the electrophilic center. Hence, nucleophiles attack the electrophilic center. Next question. Are readily distinguished by their reaction with. Okay. Again, this is a ketone. This is an aldehyde. So, tolerance reagent will be used to distinguish, because this will undergo reaction with tolerance reagent. This will not undergo reaction with tolerance reagent. We can also use Fehling solution for distinction. So, what happens is here, if I add tolerance reagent, I will obtain a precipitate of Ag. This is what? Silver mirror. So Ag is obtained as a precipitate. It's gray in color, also called silvery white. So this test is called tolerance test, also called silver mirror test, because this Ag, which is obtained as a product, is called silver mirror. Now ketones will not undergo reaction with tolerance reagent, and hence we will say that tolerance reagent can be used to distinguish this from that is the ketone from the aldehyde. Now a few minutes back we discussed iodoform test. Both of these will produce iodoform, because you can check. This also gives iodoform, and if R is CH3, then also will get iodoform. 2,4-dinitrophenylhydrazine. This is called 2,4-DNP. (2,4-DNP). So any aldehyde reacts with 2,4-DNP. Any ketone also reacts with 2,4-DNP. And you cannot distinguish, because all aldehydes and all ketones undergo reaction with 2,4-DNP. So answer is option C. Now what is the formula? How do you represent 2,4-DNP? If I have to show the structure, then okay. Now see. Hydrazine. What is hydrazine? This is hydrazine. NH2, NH2. This is called hydrazine. If I replace one hydrogen atom with a phenyl ring, this will be called phenylhydrazine. This will be called phenylhydrazine. Now, if I attach two NO2 groups, one at this point and the other at this point, now I will call this 2,4-dinitrophenylhydrazine. So this is 2,4-DNP. It's used to detect the presence of carbonyl group, which means the compound which produces some colored product when treated with 2,4-DNP contains either an aldehyde or a ketone, because all carbonyl compounds undergo reaction with 2,4-DNP. Next question. Formaldehyde and acetaldehyde are readily distinguished by reaction with. What is formaldehyde? It's methanol. The common name is formaldehyde. HCHO. This is formaldehyde. What is acetaldehyde? Acetaldehyde is ethanol. How do we distinguish this from that? So, if we use iodine and alkali, see, CH3CHO will produce iodoform, whereas HCHO does not produce iodoform in haloform test. So, here I will get iodoform, here I will not get iodoform. No iodoform, right? See, the only aldehyde which produces iodoform when treated with I2 in basic medium is CH3CHO. No other aldehyde will undergo reaction to form iodoform. CHI3 is iodoform, that is a yellow precipitate. Next question. Which is the most suitable reagent for the following conversion? Alright, what has happened? Let's see now. Okay, let's see what has happened here. CH3, CH, double bond CH, CH3, CH, double bond CH. Okay, that means the double bond between carbon atoms has not been affected. We have a ketone here, okay, and we don't have a ketone here, we have a carboxylic acid here. Alright. Fine. Also, the number of carbon atoms has changed. If you look at this compound, how many carbon atoms are there? 1, 2, 3, 4, 5, 6. There are 6 carbon atoms. Here there are 5 carbon atoms. 1, 2, 3, 4, 5. Okay. What to do now? We can check every option. But before that, I would like to tell you, because a few minutes back we have discussed that if we have, I'll write here for clarity, if we have a methyl ketone, and if I treat it with I2 in the presence of base, I get this. So this is called iodoform test for methyl ketones. Alright. Now, iodoform is one of the products. The other product is this. If I acidify this, that is if I treat this with H plus, because I want to neutralize that negative charge. See, the medium is basic. So if I don't add H plus, this is what I'll obtain. So I'll obtain a sodium salt or a potassium salt, depending on what the cation of the base was. But if I add a few drops of H plus now, I will get RCOOH. Now look at this and this. This is the original reactant. This is my final product. The number of carbon atoms has decreased by 1. Here, if there are X carbon atoms, here we'll see that there are X minus 1 carbon atoms, because there are carbon atoms in R. There is this one, the carbonyl carbon, and we have 1 carbon here. So here, if you see, this carbon is missing. Hence, the number of carbon atoms has decreased by 1. So the correct answer is option C. Tolerance reagent will not have any effect. It's a ketone, right? Nothing will happen here. And this will break the double bond as well. This is a very strong oxidizing agent. It will cleave this double bond, and then we'll get carboxylic acids. All these things will happen. Whereas clearly we can see that the double bond is still intact. So D cannot be used at all. Alright, next question. Formaldehyde reacts with concentrated alkali to form. Concentrated alkali means we can take the example of concentrated NaOH or concentrated KOH. Conc means concentrated. So the concentration of NaOH or KOH is kept very high. Formaldehyde is HCHO. If I use sodium hydroxide as the alkali, right? Now, the products of this reaction are these. This is called Cannizzaro reaction. Cannizzaro reaction. aldehyde which does not have any alpha hydrogen undergoes Carney-Zero reaction. There is no alpha hydrogen here, so this will undergo Carney-Zero reaction. Hence, these are the products, sodium formate and methanol. Now see, instead of NaOH, if we use KOH, then I'll write potassium formate as one of the products. HCOK will be one of the products. Carney-Zero reaction. Similarly, benzaldehyde also will give this reaction. We have to balance this, right? So these are the products of this reaction. Both of these are very common examples of Carney-Zero reaction. Again, this has 0 alpha hydrogen, this has 0 alpha hydrogen. Next question. Which of the following does not give aldol condensation? Does not give. So this is answer. This has 0 alpha hydrogens. A carbonyl compound which has no alpha hydrogen cannot give aldol reaction. This has 3 alpha hydrogens. This is the alpha carbon, right? This is the alpha carbon. There are 2 alpha hydrogens. This is the alpha carbon. There are 2 alpha hydrogens. C is the answer. Does not give aldol. So how do we check? We don't have to write any reaction. We just need to count the number of alpha hydrogens. If there is no alpha hydrogen, straight away we will say that yes, this will not be able to take part in aldol condensation. Carney-Zero reaction is given by aldehydes containing 0 alpha hydrogens. So C option, that is aldehydes not containing alpha hydrogen atoms. We have already discussed examples of Carney-Zero reaction. These were the most common examples. This is methanol or formaldehyde and this is benzaldehyde. Right? Okay. So C is the correct answer. Next question. Benzaldehyde reacts with formaldehyde in the presence of alkali to form. Again, this is an example of Carney-Zero reaction. Benzaldehyde and formaldehyde. Now see, we have 2 different aldehydes, right? And every aldehyde lacks alpha hydrogen atoms. In such a case, what do we do? How do we write the products? So this is called cross Carney-Zero because we have 2 different aldehydes. Right? NaOH or KOH can be used. Okay. So here we will get the products. Which products? These are the products. These are the products. Now remember, if we have 2 different aldehydes, then look at the carbonyl carbon atoms. That aldehyde whose electrophilicity is more, I mean the aldehyde whose carbonyl carbon is more electrophilic, needs to get converted to sodium salt of carboxylic acid. I repeat, out of these 2, this carbon is more electrophilic than this carbon. So I have written HCOONA, I have not written PHCOONA. To decide the major products of cross Carney-Zero reaction, you need to consider electrophilicity of carbonyl carbon. This carbon is more electrophilic than this carbon, hence this aldehyde has been converted to sodium salt of carboxylic acid. This is a shortcut. So B option is correct. What is this called? This is called benzyl alcohol. benzyl alcohol. And this is sodium formate or sodium methanoate. Now see, if I ask you what will be the major products of this Cannizzaro reaction, cross Cannizzaro. So I have benzaldehyde here, and I have 4-nitrobenzaldehyde. So what are the major products here? So we have two different aldehydes now. Every aldehyde has 0 alpha hydrogens. Now this carbon is more electrophilic because we have NO2 which shows minus M effect. Minus M effect will increase the electrophilicity of this carbon, so this is more electrophilic. So the major products will be these. I hope now the concept is clear. Very, very important. Aldol reaction, Cannizzaro reaction, haloform reaction, iodoform test, all these are extremely important in this chapter. Okay, next question. Which of the following can be converted to CH3, CH, double bond, CH, CH? Okay, now the common name of this compound is crotonaldehyde. You must remember the common name of this compound. This is called crotonaldehyde. Look at this compound. If I ask you to identify alpha carbon, then this is alpha and this is beta. Can I say that this is a compound in which we have a double bond between alpha and beta carbon atoms and the principal functional group is aldehyde? Such a compound is obtained on dehydration of an aldol. What is an aldol? An aldol is a beta hydroxy carbonyl compound. If I perform condensation of aldol, that is a dehydration, then we get the final product of this category in which we have a double bond between alpha and beta carbon atoms. So this is called an alpha beta unsaturated aldehyde. An alpha beta unsaturated carbonyl compound is obtained on condensation of an aldol. So which of the following will give me this as the final product? So let's perform aldol condensation. Now this cannot undergo aldol condensation, we have discussed already, because this lacks alpha hydrogen, so this is out of discussion. The remaining three compounds are capable of undergoing aldol reaction. Let's randomly take B, that is CH3CHO, acetaldehyde. And if I start showing the mechanism, then this is the first step, that is formation of enolate. One alpha hydrogen will be abstracted, right? Alright. After that, this will attack another molecule of ethanol. So this will attack. This is the nucleophilic addition. Right? And after this, if I neutralize it, adding a few drops of H plus, then I'll get OH here. And now if I perform condensation by heating it, then this OH goes out and one H from this carbon goes out, and hence I end up with crotonaldehyde. Hence, option B is correct. So B is the correct answer. Right? This is the aldol. This is beta hydroxyaldehyde, and this is the product obtained after dehydration of aldol. This is called alpha beta unsaturated carbonyl compound. If I don't heat, then I'll obtain this as the final answer. I will say this is the aldol, this is the final product if no heating is carried out. Right? I'll not check the other options because already I've obtained the required product using this as the reactant. Next question. The product of reaction with primary amine with aldehydes is, okay, interesting one. This is an aldehyde. A primary amine may be represented like this. Remember, if I have a primary amine or NH3 or hydrazine or NH2OH, any of these, then the shortcut to form the final product is same everywhere. Now, what is the shortcut? Remove oxygen from the aldehyde or ketone and remove H2 from any of these. I mean H2 attached to the nitrogen atom. And then just join these two with the help of a double bond. So in this case, I will obtain this as a product. A double bond is there between carbon and nitrogen. So let's check the options now. A double bond is there between carbon and nitrogen atom. Okay, so C is similar. Now see, if I take this as R dash and this as R, then I'll obtain this as a final product. Isn't this same as C? So this is called a substituted imine. Substituted imine. Imine indicates double bond between carbon and nitrogen atoms. Imine. Check the spellings. Don't go wrong. See, amine is different, imine is different. In imine, we have a double bond between carbon and nitrogen atoms. So a 1 degree amine is a primary amine. Any primary amine is of the form RNH2 or R-NH2. Hence I wrote a 1 degree amine. This is an aldehyde. So basically this is a condensation reaction. You remove H2O in this manner. H2 from the nitrogen containing part and oxygen from the carbonyl compound. So always remember that the double bond in the product must be between the carbonyl carbon and the nitrogen of the other compound. NH2OH is called hydroxylamine. The product of a carbonyl compound with NH2OH is called an oxime. Very, very useful. Sometimes they ask you, what is an oxime? So what is an oxime? If I write this aldehyde and let's say I am reacting this with NH2OH, remove H2, remove O, so this is what I'll obtain. Since this oxime has come from an aldehyde, this is called an aldoxime. Likewise, if I take a ketone, then I'll get an oxime and that is called ketoxime. Right? Geometrical isomerism is possible around this double bond in aldoxime. In ketoxime also, geometrical isomerism will be possible if R and R dash are two different groups. But if both R and R dash are same, then there is no scope for geometrical isomerism in ketoxime. Similarly, if this is H, then H and H will become same, and then that aldoxime will not be capable of showing geometrical isomerism. So be careful. Sometimes they ask you how many oximes will be formed if this reacts with this, and including stereoisomers, you have to report your answer. So if the demand of the question is such, then you have to count all the stereoisomers. Hence I talked about geometrical isomerism here. Next question. Brady's reagent is, okay, so Brady's reagent is nothing but 2,4-DNP. 2,4 DNP, 2,4-dinitrophenylhydrazine. So this is the compound, Brady's reagent. Any carbonyl compound will definitely react with Brady's reagent to form a product which is orange or yellow in color. This is the crux of the entire story. Okay. Next question. A compound with molecular formula C3H6O does not give silver mirror with tolerance reagent, but forms oxime with hydroxylamine. Compound will be. Now, this is clear that the compound definitely does not contain any CHO. That means it does not contain aldehyde group, because it does not give silver mirror test with tolerance reagent. See, all aldehydes react with tolerance reagent. If the compound is a carbonyl compound and is not undergoing reaction with tolerance reagent, that means it is a ketone. And here we have been told that it forms an oxime with hydroxylamine. Yes, oximes are formed by ketones as well. Just now we discussed oximes. So it's a ketone. C3H6O. C3H6O. This is an ether. This is an alcohol. This is an aldehyde. All these are ruled out. The only option left is this. This is a ketone, and also we know that ketones react with NH2OH to form ketoximes, and ketones will definitely not reduce tolerance reagent. Ketones will not reduce Felling's reagent. So D is the correct answer. Next question. Hexanal and acetophenone are distinguished by reagent. What is hexanal? This is hexanal. This is called hexanal. And acetophenone is this. This is called acetophenone. Okay. Are distinguished by reagent. Now see, Felling's solution will undergo reaction with this, because this is an aldehyde, but this is a ketone. This will not undergo reaction with Felling's solution. So we can say that on the basis of Felling's reagent or solution, we can distinguish this aldehyde from the ketone. Next question. Carbonyl group is converted into methylene group by, what is methylene group? That means CH2. So basically they are asking us regarding this conversion. Right? How is this obtained? We know that a ketone or an aldehyde can be converted to this. That is, if we wish to remove oxygen, and in place of oxygen, if we want to add hydrogen atoms. Now this can be done by using Clemmensen reduction. This can be done by using Wolff-Kishner reduction, and also this can be done by using red phosphorus HI. Now what is Clemmensen reduction? Basically, we treat an aldehyde or a ketone with zinc amalgam and conc HCl. This is called Clemmensen reaction. So this is Clemmensen reaction. So A is the answer. If you perform normal hydrogenation of a ketone or an aldehyde, then you will obtain an alcohol. And a carbonyl compound can be converted to an alcohol by using hydrogen in the presence of nickel. That is called catalytic hydrogenation. So that is what they have mentioned in option D. Okay. Next question. When acetaldol is heated with base, then unsaturated product will be. Now what is this acetaldol? Acetaldol is an aldol obtained from acetaldehyde. This is acetaldehyde. If I subject this to aldol reaction, then I will get acetaldol. So this is acetaldol, and now if I heat this with base, if I heat this in basic medium, then condensation happens. I'll remove OH from this carbon. This is the beta carbon with respect to aldehyde, and this is alpha carbon. So when we perform dehydration of an aldol in basic medium, we remove OH and we remove one hydrogen atom from the alpha carbon, and we place a double bond between alpha and beta carbon atoms. Hence I will obtain this. So this is an alpha beta unsaturated carbonyl compound. Unsaturated indicates that there is a double bond between carbon atoms. So basically it's an aldehyde because the principal functional group is aldehyde here, right? Okay, so aldol condensation is extremely important, Carney-Zero is extremely important, iodoform test is extremely important. We have discussed these in great detail. Reaction with NH2 OH to form oximes is extremely important. Oxidation reaction using KMNO4 or K2Cr2O7 in acidic medium is extremely important. So quickly I will talk about that. Let's say we have an aldehyde, and if this aldehyde is treated with acidic K2Cr2O7, that is K2Cr2O7 is acting as an oxidizing agent, and if the medium is acidic, then I'll obtain this as the product, carboxylic acid, and also CrO3 in the presence of H plus also will obtain RCOH, right? And if I use KMNO4 in the presence of base at high temperature followed by acidification, then also I will obtain RCOH, right? Very, very important. So an aldehyde can be converted to RCOH, and if I treat this with Tollens reagent, and then after that if I add a few drops of acid, then also I will get this. So all these are oxidizing agent. So an aldehyde can be oxidized to carboxylic acid. But remember, if RCHO is treated with PCC, then nothing happens. That is why we use PCC to convert a 1-degree alcohol to an aldehyde. Okay, so hope you have enjoyed the session and we have discussed some important questions. So I want to make sure that you are thorough with these things. So please revise these important reactions again from NCERT. Okay, all the best. See you soon. Thank you.